We will begin on our new topic, sampling and variability. And let me start by defining what a population is. A population is the entire complete set of individuals, objects, measurements, or events that a researcher is interested in studying in the whole group about which we want to draw our conclusion. And the key characteristics of a population are: the ultimate goal of a statistical study is to learn something about this population. So we say it is therefore the target of inference. A population is defined by a specific criteria. A population must be clearly or must be precisely defined by one or more characteristics that all its members share. This could be anything from all students in schools in Kenya. Also, the population can be finite or infinite. Most real-world populations are finite, like all students at a university, but theoretically, populations can be infinite, like all possible outcomes of flipping a coin forever. A population has its parameters fixed, but often unknown. A parameter is a numerical value that describes the characteristics of a population. Common parameters of the population are mu, written as IU but pronounced as mu, and the population proportion, written as P, lowercase. The values are defined as a fixed constant, but because we rarely measure the entire population, they are usually unknown and must be estimated. In education planning and in policy, we use populations. And here are examples of a population in education planning. 1. All 5,000 students in secondary schools in a specific school district. This population might be studied to understand the overall gender parity in the STEM course enrollment. 2. Every single teacher in a state public school, that is a place could be surveyed to gauge the training needs for facilitating mixed gender classroom discussion effectively. Also, the population of a public university could be studied. Now, apart from the population we have discussed above, I want us also to define what a sample is. A sample is a subset or a smaller group selected from the population. It is part of the population that is actually observed, measured, or surveyed in a study. There are samples. Let us look at the characteristics of a sample. This is the source of data. We collect information from a sample because it's often impractical or too expensive or impossible to study the entire population. It must be representative. The fundamental purpose of sampling is that the sample characteristics should be accurately reflect the characteristics of a population. A representative sample is a miniature version of a population without systematic bias, and this is the most effective through the random sampling method. Also, a key characteristics of a sample, its statistics are known but variable. A statistic is a numerical value that describes a characteristics of a sample. Common statistics are sample mean, written as X bar, and the sample proportion, written as P hat. We can calculate them directly from our sample data. However, if we draw different samples, the value of the statistics will change. This variation from a sample to sample is called sampling variability. Examples of samples include: we are having a representative of about 3,500 from all the grade 3 learners in CBC in the country. So when we sample these 3,500 learners and we want to know their characteristics, these students or these learners are individually assessed on letter sounds, reading fluency, and comprehension. And through that sample, we can make a conclusion about the entire population of grade 3 learners. Also, for the teachers, we might take about 800 teachers to participate in a study of professional teachers' professional development. This sample completes a detailed survey and participates in focus group about their challenges with the implementation of the new integrated, for example, STEM curriculum. The data from this sample may reveal that rural areas feel unprepared in the STEM subjects. Then the education department uses these inferences to design a targeted teacher professional development program for the rural teachers rather than one-size-fits-all approach that could be less effective. We have so many examples we can say to give on samples. But let me look at why we should use a sample instead of using the entire population. The first reason is visibility. It is impossible and prohibitively expensive to test every individual in a population. Sampling makes larger scale data collection practical. 2. Timeliness. Policies often need to be made quickly, and collecting data from a sample is far faster than conducting a fully census, allowing for more response decision making. Third reason is the depth. Because a sample is smaller, researchers can often collect richer, more in-depth data through interviews or detailed observation that couldn't be possible with entire population. The fourth reason, which is my final reason here, is accuracy. A well-designed random sample provides a statistical sound basis for inference. It reduces the risk of basing million-dollar policies on a few anecdotes or unrepresentative case studies. Finite and infinite population. In division, a finite population is one that is limited in size and can be completely enumerated. In this context, sampling is typically done without replacement, meaning once a number is selected for the sample, they cannot be selected again. A finite population in education is a clearly defined limited group where every member can, in theory, be listed or counted. Key characteristics is a fixed, knowable size, most cases represented by capital N. Because the population is bounded, when we draw a sample, we do so without replacement to avoid the statistical inefficiency and logical error of assessing the same unit multiple times. Examples of finite population in education planning and policy studies. All students in a school, for example, they might be 450, 500, 1,200 at a particular time. For example, we say all students present in a term in a school, they might be 450 in third term. That is a finite. They are countable population. Also, we might talk of schools in a region, 2,000 schools in Western region, or 4,000 schools in the Rift Valley region. They are countable, and thus it falls under the finite population. Why is it finite? They are countable and enumerable in a given region. If they are not enumerable, then we will not talk of countable number of schools. Also, we look at teachers in a given county. We might talk that in a given county there are 750 certified teachers employed by the Teacher Service Commission. They are accountable and they are in a roll call somewhere. So because they are countable, they are enumerable, we say they is a finite population. Also, we can talk about the textbooks sent in a given school. Because the number of the textbooks is known, we say that it's a finite, countable number. And here, whenever school, we can do assembling whenever these books are sent in a school. And we do sampling without replacement in practice. For example, the district may need to check for known printing defects in these books. A quality control team randomly selects about 200 textbooks from the inventory for inspection. At each book is pulled and inspected, it is set aside. This is critical because the inspecting team inspecting the same book twice will provide no new information and waste of resources. Understanding the true effect of the rate of populations here. We have seen that we are doing selecting without replacement or sampling without replacement. Now, I want us to move further and see the critical underlyings of this sampling of finite population. Why is without replacement why is it critical for policy planners or the planning student? Logical soundness and efficiency. It makes no logical sense to survey the same teacher, to survey the same student twice, or inspect the same book twice. Sampling without replacement is the most efficient way to gather the maximum amount of unique information from a limited sample size. Another reason why sampling without replacement is critical is resource allocation. Accurate data from a properly drawn sample ensure the resources are directed where they are most needed. For instance, if a sample of schools, which is done without replacement, reveal that science lab deficiencies are widespread, the resulting policy will be a broad infrastructural program. If the same few schools were accidentally sampled multiple times, the problem might be seen concentrated, leading to a less effective targeted policy. Also, why do we sampling without replacement? It's for statistical purposes, and this leads to statistical accuracy. Using a sample without replacement for a finite population requires the use of a finite population correction, FPC factor. Very important. We are going to look at this one in more detail. The finite population correction provides a more accurate and narrower estimate of the standard error. This means the confidence intervals around estimates will be more precise. Basing multiple million-dollar plus decision on a precise data is critical. So it's very important that we look at this and we see how we use the finite population correction factor in doing the estimation and sampling